Hello. Periods 1 and 2. We are talking about independent and dependent events today. So you should be able to determine whether an event is independent or dependent. An independent event is an event, one event does not affect the other event. You will see the words without replacement in the words. You will also know that, like, if I flip a coin and I spin a spinner, they don't have any effect on each other. So those would be independent events. The other one that we're going to talk about are dependent events, where one event does affect the outcome of the other event without replacement. For example, if I have a deck of cards and I tell you to pick a card, look at it and hang on to it, and then pick another card, you would know that the first time you had to pick, you had 52 to pick from. The next time, you didn't replace the first card, so you only have 51 to choose from. Okay, so independent and dependent. It says, tell whether the events are independent or dependent. In a class of 30 students, a gym teacher randomly chooses, that's a key word, a student for a demonstration. From the remaining students, the teacher randomly chooses another one. Well, on the first time, you had 30 to choose from. Then you call on another student, and you have 29 to choose from. So these would be dependent events. You roll a number cube, B, and then you roll a number cube again. Well, when you roll it the first time, you have 6 outcomes on the first roll, and then you have 6 outcomes on the second roll. One does not affect the other one, so it's independent. So look at the next one, the checkpoint. Tell whether the events are independent or dependent. You randomly draw a numbered ball from a bowl. Then you put it back in the bowl and you randomly draw another one. Well, because you are putting it back in the bowl, you still have the same number to choose from. So these would be independent events. And what we do here for independent events, if you have the probability of A and B happening, that's the probability of A times the probability of B. I'll give you an example. If I wanted to know the probability that I roll a 6 on the first roll, and I have probability I roll an even on the second one. One roll does not affect the other one, so we take the probability of a 6, which is 1 out of 6, times the probability of an even is 3 out of 6, which is 1/2, we know, so that cancels to a 2, and we get the probability of rolling a 6, and then an even is 1 out of 12. Each student in your class is to write a report on one of the 13 states in the United States. Your teacher is allowing each state to be randomly chosen by more than one student. What is the probability that you and the student who sits next to you choose the same state? So it's the probability of the same state. We don't put it back, or we do put it back, sorry. We can get more than one kid getting the same one. So the probability of the same, I get 1 out of 13 times probability that my neighbor gets it is 1 out of 13. So we have a 1 out of 169 chance that we both get the same state. So the probability of dependent events, if you have replacement, you would take, if you want to know the probability of A and B, you take the probability of A times the probability of B given A. Yeah, what does that really mean? Okay, if I have 3 blue marbles and I have 4 red marbles, and I do not, or I do have replacement, so I'm gonna know what's the probability that I draw a blue one, followed by the probability that I have a red one. Well, I'm not replacing it, so the probability of a blue one would be 3 out of 7. I don't put the marble back in the bag. The probability that I pick a red one would be 4 out of 6. There's one less in the denominator. Okay, so we can get 12 out of 42, or you could have reduced this to be 2 over 3. So we get the probability that I pull a blue one, don't replace it. We do replace it. Good grief. That would be 6 out of 21. Okay? In a box of 15 parts, 4 of the parts are defective. You randomly choose a part, then you randomly draw a second part without replacing the first part. Find the probability both are defective. So the probability of a defective one times the probability of another defective one. Well, there are 4 out of 15 that are defective. Times, well, the next one could be 3 defective out of 14. So we get 12 out of 210. And I want to write this as a percent. When you punch that in the calculator, it's approximately 6% of chance that happens. So we're going to practice these. You have to decide whether it's independent or dependent. A student spins a spinner and chooses a Scrabble tile. A spinner does not have anything to do with a Scrabble tile, so those are independent. A boy chooses a sock from a drawer of socks, then chooses a second sock without replacing the first one. Because he is not, or she is, he is not, these are dependent events because he did not put the first one back in. A student picks a raffle ticket from a box, replaces the ticket, then picks the second raffle box. Because it is replaced, it is independent. We are now going to find the probability. So it says, picking a red checker from a bag of 9 black checkers and 6 red checkers, replacing it and picking another red. So we want to know the probability of a red, replacing it, and find the probability of another red. Well, how many are reds? Well, there are 6 out of 15, right? We replace it. Another red would be 6 out of 15. I would reduce both of those first. So we get 2/5 times 2/5, which would be 4 over 25. Okay, so now you're picking a black checker, replacing it, and picking a red one. So it's the probability of a black one, replacing it, followed by a red. Well, the probability of pulling a black checker is 9 out of 15. Times then probability of a red one would be 6 out of 15. I'm going to reduce both of those. So 9 over 15 reduces to 3 over 5 times 2 over 5. And we get 6 out of 25. Next one, it says rolling a 1, 2, or 3 on the first roll of a number cube, 1 through 6, and then rolling a 4, 5, and 6. So we have the probability of a 1, 2, and 3 times the probability of a 4, 5, and 6. Those are independent because you're rolling them twice. Well, isn't that 1/2 times 1/2? Which would be 1/4. All right, solve. Randy has 4 pennies, 2 nickels, 3 dimes in his pocket. If he randomly chooses 2 coins, what is the probability that both are dimes? Well, when he pulls the coins out, he digs in his pocket. He doesn't put one back, so these are dependent events. So we want to know the probability that it's a dime, followed by the probability it's a dime. So how many are dimes? 3 out of 9 times, well, if he gets a dime, the next one, it would be 2 out of 8. I'm going to reduce this to 1/3 times 1/4, which would equal 1 out of 12. Okay? Makes sense?